Okay, guys, I'm going to have to repeat that stuff here, but numbers behave in certain ways, and they have certain rules, and those rules have names, and you're going to see these in math courses from now until the day you die. Maybe not until the day you die, but many more math courses after this one. But this first one here, the additive identity, that just means that any number, if I add 0 to it, I keep the same number. 5 plus 0 is 5. 10 plus 0 is 10. 0 plus 9 is 9. Okay? So if I ever add 0 to a number, I keep the number. Okay? 0 is known as the additive identity. So if I ask you on a test or a quiz or something and I say, hey, Kentaro, what is the additive identity? Kentaro, what would you say?
It's the sum of a number plus 0.
No. What would I say? What is the additive identity? William?
A number plus 0.
No. What is the additive identity? Will? 0. Good. Okay. The sum of a number and the additive identity, which is 0, is always the number. Okay? Now, I want you to take that same idea and plug it in for multiplicative identity. Let me ask you this. This is a nice, neat word here, Milan. Use that word, you sound smart, even though we know better. Right? I'm just kidding, Milan. Milan's not smiling. He looked like Julian did a minute ago. All right? Milan, what do you think? Milan, what is the additive identity? No. What is the additive identity, Kentaro? No. Rex, what is the additive identity, Rex? 0. What's the multiplicative identity? It's the same concept. Dane? Times 1. 1 is the multiplicative identity, because anything I multiply by 1 stays the same. Anything I add to 0 stays the same. Anything I multiply by 1 stays the same. Okay? All right. Next up, commutative property of addition. In a sum, you can add the numbers in any order and you still get the same result. Okay? The associative property of addition means that it doesn't matter how we group the numbers, we're still going to get the same result. Okay? Okay, guys, I'm sorry, we were saying about the associative property. We can group these things in any order, and regardless of the order that we do them in, we're still going to get the same thing. These properties apply to multiplication as well, multiplication and addition. If I can multiply numbers in any order, I still get the same thing. Okay? I can group them and do them in any order, and I still get the same thing. Okay? Think about these two words. Associative means what numbers are associating with the others. In this first one, 9 plus 6 they're grouped together, and in the second one, 6 plus 2 are grouped together. Okay? Commutative, people commute to work, they move from one place to the other. The commutative property says, you know what, the numbers can move too. I can put -5 in front, I'm still going to get the same thing when I multiply them. All right? That's the general idea. Now let's look down here at example number 1. And it says, you buy a portable CD player. I don't know why you would do that, but maybe back when they wrote this book, people actually had portable CD players, back before Dirt and iPods and that kind of stuff. But you buy a portable CD player for $48 and rechargeable batteries. What a concept. For $25. And a CD case to carry all those flashy CDs in. Pretty nifty. For $12. Find the total cost. Now, that's a simple problem. What do I need to do here? How do I find this problem? Will K? Just add it all up. Why don't you tell me what to write for us to do that? 48 plus 12 because it fits well. Yes. Thank you, sir. Then plus 25?
Yeah. And then I will get 85.
This is 60.
Yep.
Plus 25 is 85. Oh, not 80. Old man. 60 plus 25 is 85. And that's our answer. Does it matter what order I add all those things up, Rex? No. And why not? What property tells us that it doesn't matter, Ross?